So if you have 4 minus 2y, what you really have is 4 plus negative 2y. Hi, Jalen. So in that case, it's actually negative 2. Negative 2 is the coefficient of negative 2y. Okay, so subtracting polynomial expressions. Last week we learned how to add these guys, all right? And we had 3 methods to do that. We used that website where we used algebra tiles. We had the horizontal method and the vertical method. Sorry, wait, horizontal and vertical. And when we subtract polynomials, you're going to see we use the same 3 methods. We just have to change it from a subtraction problem to an addition problem. So it's actually pretty, one little change, and then it's exactly what we did last week. So this goes with 17.3. How do you subtract polynomials? And your learning goal is I can explain how to subtract polynomials. So just to review, from last week, we learned how to add polynomials. And we did that by combining like terms. Like terms have the same variable, and they have the same power on the variable. So we also learned with algebra tiles, but then we learned the vertical method, okay? And so if we had these 2 polynomials, we had to make sure that if we were missing a certain type of polynomial, we added a 0 placeholder, like the 0x squared goes here because there wasn't an x squared term in the first polynomial. And then for the second polynomial, I had to add 0y squared because the second polynomial did not have a 0y squared. So this method, you had to add 0 placeholders, and then you just added the columns, either from left to right or right to left, it didn't matter, and then simplify it at the end. So if you did have any zeros, you wouldn't write that term when you're all done. It was just the simplified version at the end. Horizontal method, instead of writing them stacked, what you do is you rearrange this long addition so that like terms are together in parentheses. So you can put the 2 terms that are together, the x cubed terms together, and then there's only one x squared term, so it's by itself in parentheses. And the 2 x terms are together in a set of parentheses, and then simplify each set of parentheses to get your simplified polynomial. So this is how we added polynomials, and we're still going to be essentially adding polynomials because the way we add polynomials, the way we subtract polynomials is we're just going to switch it to an addition problem. All right, so we're back in Mathagon. All right, this is mathagon.org/polypad. Everyone should have this open in their Pear Deck. And, the key is here again for what these represent. The number 1 is this little orange one. -1 is this little pink -1. An x term or a single variable is this elongated rectangle here, this green one. And then a negative x term is this elongated rectangle, this pink one. And then an x squared term is the blue. Negative x squared is the bigger pink square. So basically, to subtract polynomials, all we have to do is remember that subtraction is equivalent to the addition of the opposite. Kind of like in that very first slide we saw, we had the subtraction sign between the 2 terms. So you had to rethink about it as adding the opposite. And that's why the coefficient of that y term was -2. So we're going to find this sum here, 2x squared plus 4 minus 4x squared. And in order to do that, we're going to rewrite it so that it's an addition problem, and then we just go back to what we already learned about last week. So I'm going to use this text box tool, and up here I'm going to type out 2x to the second power plus 4, close parenthesis, minus, open parenthesis, 4x to the second power. close parenthesis. All right, so right now what I have is I just have what's here typed out here. And I'm going to change it to an addition problem by adding the opposite. So this turns into, well, the first polynomial does not change at all. So we're just going to retype the first polynomial as 2x to the second power plus 4. And now instead of subtraction, I'm going to put addition. And what I'm going to do is change the sign of each term in the second polynomial. There's only one term in the second polynomial. So right now it's positive 4x squared, so it's become negative 4x squared. And now I can represent this with algebra tiles. 2x squared, we have 1, 2, plus 4, so that's 4 of these. And then negative 4x squared. That's 4 of these. And you can drag them out individually, or you can also press this copy button to make copies a little bit quicker. All right, so 2x squared plus 4 is on the left, and then I'm adding to it negative 4x squared. And that's what I have on the right. If you press shift plus then that, it turns into an exponent. Really? I want to try that. It didn't work for me on here. Did it work for you on this Mathagon website? Really? Well, that's fantastic. So, don't know why it's not working for me. Press shift plus that, then the number. Plus shift and that together. Okay. You have to hold shift. I hold shift, I just get a bunch of those. It's all right. If it works for you, great. If it doesn't, don't worry about it. You also have this drawing tool that you can use. Okay, so do you remember how to add these polynomials? You have to create zero pairs. So if they're the same shape, but opposite signs, they create a zero pair. Same shape, but opposite signs, they create a zero pair. So once I've created all the zero pairs I can, what I have left over is the solution. So we have 2 of these, and we have 4 of these. Okay, and so then we just kind of, what is this? This is our answer. So the text box here, I'm going to try the trick again. Let's see if it works. We have negative 2x, hold shift. No. It's not working for me. That's all right. I don't mind. There we go. Negative 2x squared. Shift plus that, then let go of shift and tap any number. International keyboard. All right, I'll try it on the next. Yeah, I don't think I have the right keyboard then. Because I'm not on a Chromebook like you guys. I'm on a ThinkPad. It's a little bit different, so maybe that's the problem. But okay. I do appreciate you guys telling me all this cool stuff, so I have to change it in my settings. I do have to practice. You're absolutely correct. You sound like a teacher. Okay. And there you go. That's our answer. So that's how you use algebra tiles. Okay. Well, let's look at our other methods. Okay. So the second method, subtracting using a vertical format. So again, our first step is going to be to rewrite the subtraction problem as an addition of the opposite. And so here we have 5x plus 2 minus negative 2x squared minus 3x plus 4. And so the first step here is to rewrite subtraction as addition of the opposite. So this is step number, nope, I'll do step 1. Okay, rewrite subtraction as addition of the opposite. And, you know, that's where you have those things like drop the line, change the sign, or add the opposite. So that's what they did here. This is turning into plus, and then in order to add the opposite, now we have more than one term in the parentheses. So I have to change the sign of everything inside. So this becomes positive, this becomes positive, and this becomes actually negative. And that's why we have positive 2x squared plus 3x minus 4. Using the vertical method, we're going to line up our like terms. So let's see, we have a 5x term and another x term over here on the second one. So these guys will get lined up. That's why there's 5x and 3x here. We have a constant of 2 and a constant of negative 4. So we have to make sure those guys are lined up. And then we have an x squared term in the second polynomial, but we don't have one in the first polynomial. So when we're missing one, that's when we put in the 0 placeholder. Okay, so we use 0x squared as a placeholder. And then we combine our like terms. This was step 2. And then we combine our like terms. You can add from left to right or from right to left. It doesn't matter which way you choose to add. But 2 minus 4 is negative 2. 5x plus 3x. So after you combine like terms right here, we're not going to solve this. This is our answer. 2x squared plus 8x minus 2. This is done. Okay, because there's no like terms left to combine. X squared is an x. They both have an x, but they have to have the same power in order to combine them. So we're just going to leave it like this. This is our answer. I think I'm answering your question, Marnaya. Right, and so if we look at the second example up here, we have y squared plus y minus 1 minus negative 2y squared plus y plus 1. So this is a subtraction of polynomials. So our first step here is to rewrite it as addition of the opposite. So you can go through and you would change this to addition, but then you have to change the sign of everything, every term in the second polynomial. All right, so right here, this is just for the symbols. All right, this turned into a plus. This turned into a plus. It's positive 2y squared. This turned into a negative y or minus y. And this is minus 1. And so once you've changed it, so that's an addition problem. Now you can set it up for the vertical method. And so you have to make sure that you are only combining like terms. And there's lots of, let's see, we're using y now. So there's a y squared, and there's another y squared. So that's good. So I could put those here. I'm just going to try to write them because, no, way too big of a thing here. Y squared. Okay, and then under that, I'm going to put the 2y squared. All right, so next I look for the y terms. We have common terms that are just both y. Yes, there's a y term here, and there is a y term here. So this is plus y, and then this is minus y. And last, we're going to do our constants. We have -1 and -1. So we'll go ahead and put those in. -1, -1. All right. So once you've set it up, I didn't actually have to use any zero placeholders this time because I wasn't missing anything to have to use one. You only have to put those zero placeholders when you're missing a like term to go with, both polynomials. So now we're just going to add either from left to right or right to left. It really doesn't matter. Let me see how you guys are doing on this. So go ahead and try to add these up. See what you get. One thing that'll help you when you're adding them is if you don't see a coefficient, put it in. So I see that this 2y² has a 2 in front of it, but the y² doesn't have anything in front of it. And I don't want to forget that there really is an invisible one here. 1y². With plus y and minus y, again, I don't see something there, but I can write it as plus 1y minus 1y. So sometimes that helps a little bit when you're adding. So you know what to add. You're just adding the coefficients and keeping the variable part the same. Okay, so right here, this person, the first term they wrote was 3y². That's correct. 1y² plus 2y², you add 1 and 2 together, that gives you 3. And so this column here is 3y². What about our next term? 1y minus 1y. What would go there? I have 10 of you guys. How many of us are in the meet now? I have messages. So it is going to be 0. Okay. Remember, same variable y's. We just add the coefficients. 1 minus 1. Angel, I think you're answering this the last part of it, which if that's what you're referring to, the purple, then yes, you are correct. -1 plus -1 is -2. Okay, so good. So let me go ahead and just add that in. We have plus 0, and then we have minus 2. And so now we've had this, all the steps are the same, except here it says simplify, because we can simplify. We weren't able to always simplify, but there's a 4th step here. And basically, you know to simplify when you have a 0 term. You want to get rid of that. And so our final answer would then be 3y² minus 2. Okay, you guys have any questions on the vertical format? So I have 22 of us in the meet, and 12 of us in the pair deck. If you don't join the pair deck, then you get marked in attendance that you are non-responsive. So yeah, you join the meet, that's good, but you have to participate to get your full attendance credit. Alrighty, so I'm going to move us to the next slide here. This is all being recorded, so you can go back and add to any of these slides at the end. I'll put you on student paste. Third method, subtracting polynomials using a horizontal format. Okay, once the subtraction problem has been rewritten as a sum, the polynomials can be added using the horizontal method that we did last week. So this method uses associative, commutative, and distributive properties to group and combine like terms. And so if you look at the first example here, A, they have 2q squared minus q minus 8. That's your first polynomial. And we're subtracting the second polynomial of 2q squared plus q minus 4. First step here is to rewrite the subtraction as addition of the opposite. That's the same first step for all these methods, is you change your subtraction problem into an addition problem. And in order to do that, you are basically distributing a -1 through all the terms. So you're adding the opposite, which looks like this. This becomes a plus. This becomes a minus. This becomes a minus. This becomes a plus. So minus 2q squared minus q plus 4, and it goes from subtraction to addition. Then your second step here is to group like terms together. So we're using the commutative property to do this step. So like terms, you know, we can use like a color to identify them. 2q squared would match up with negative 2q squared because they both have a q squared. That's why they're both together right here. And then negative q and negative q are both with a q, so those are together. Negative 8 and positive 4 are together because they're both constants. So you rearrange the stuff into groups of parentheses. And then you just simplify each set of parentheses. And then that would be your answer here. This is probably the method that I prefer, but you can use any of these methods. You know, they will all give you the same answer. It's a little bit different depending on how you set it up. All right, 2q squared minus 2q squared. Whenever you have something and you subtract the exact same thing from it, that's always equal to 0. So that's 0. It actually just cancels out entirely. Negative q minus q. You don't really see what you have going on. You can add in your coefficients. -1 minus 1, -1 plus -1 is negative 2q. And then negative 8 plus 4, when you add integers of opposite signs, you actually subtract. You take their difference. Okay, the difference between 8 and 4 is 4. And since negative 8 has a larger absolute value than 4, negative 4 is what we get here. So this is the horizontal format. And then we're going to do this example here. 2ab minus b plus a is the first polynomial. Second polynomial that we're subtracting is 2b squared plus b plus a plus 4. We're going to go through the same steps. Rewrite the subtraction as addition of the opposite. Drop a line, change the sign. Okay, so this becomes plus, this becomes minus, this becomes minus, this becomes minus, this becomes minus. And so they want us to write this out here. b squared minus b minus a minus 4. And then we're going to regroup all the like terms together. So I do want you guys to try to do that. And, since you can draw on this slide with all these different colors, go through and identify the pairs of like terms, okay? There's a AB term type of term, there's a B term, there's an A term, there's a B squared term, and there's a constant term. So there's lots of types of terms here. There's actually 5 different types of terms. So if you're using color to go through and just like underline or highlight the different types of terms, there's actually 5 types of terms in this example. So we have the 2AB term, which is one type of term. And there's not another one like that. We have a minus B, so a B term. Over here I also have a B term, another minus B. A plus A, a minus A. So we have a pair of like terms that have an A. And then, see, we have this minus 4, which is a constant. Then we have this 2B squared, which is its own type of term also. Now we can only group together like terms. So since there's 5 types of terms, my answer may have 5 terms in it if nothing cancels out. So we're going to type that all out. So I am going to type negative 2b squared first. Maybe I will just use the pencil colors to do it instead. 2b squared. There's only one of those. Then I'm going to put the 2ab term next, plus 2ab. And then I could put these b terms next, or the a terms. I don't know how much it matters. But these I will put in parentheses because, there are 2 of them. Negative b, minus b. And then my a terms, there's 2 of those, so I'll add those in parentheses. A minus a. And I have minus 4 at the end. One of these, either purple or pink, one of them is going to cancel out to 0. What cancels out to 0? Do the b's disappear or do the a's disappear? Yeah, not b's. I appreciate your participation, though, Angel. Oh, see, you do have the exponents. That's so nice. I need to change my keyboard. I don't even know how to do that, but I'll figure it out. Just not right this second. Okay. Yeah. So a minus a is 0. Negative b minus b is actually negative 2b. So I'm realizing I forgot something. I missed a negative right here. So this is supposed to be negative. Okay, see that? Negative 2b. Sorry. Totally my fault, which means I gotta carry that negative through. This is negative 2b. All right, do you guys have questions about this method? We looked at the 3 different ways, the 3 methods. There's algebra tiles, vertical, horizontal. And the main idea here is that if you're going to subtract polynomials, turn it into an addition problem and really just add the polynomials. That's good, Angel. Cool. Yeah, I like this math that we're doing right now. I think it's fun. I think a lot of math is fun, but yeah, this math I do think is fun. All right, so we have one more slide. I am going to move you guys forward, and then I'll leave it in student pace so you can go back. So at this point right now, it is on student pace, but I did kind of force you to go to the slide we're on. So subtract the polynomials using any of the 3 methods you prefer. The number of gallons of water in a leaking pool is determined by the rate that the water is filling. 8g squared plus 3g minus 4, and the rate that the water leaks from the pool, 9g squared minus 2g minus 5. Where g represents the number of gallons entering or leaving the pool per minute. Write an expression for the net change in gallons per minute of the water in the pool. Then find the change in the amount when the rate g is 5 gallons per minute. So it's asking us to do a couple things here. One, it's asking us to subtract this polynomial and this polynomial. All right. We're going to do that by writing an expression for the net change. That means subtract. Then the second thing they want us to do is to find the change in the amount when the rate g is 5 gallons per minute. So for a specific value of g, we're going to evaluate it. 8g squared plus 3g minus 4 and 9g squared minus 2g minus 5. You're going to subtract those however you choose to. You can use the polypad if you want to. You can use the horizontal. You can use the vertical. All right. One thing though, when your coefficients get bigger, it's a little bit more tedious over here with the algebra tiles. So like if I want 8g squared, that means I need 8x squared tiles, and you can use this to get 8 of them, right? So this method might be a little more time consuming, but it might help you understand it better. There's 3 for 3g and minus 4 for those. Oops. All right. So before I could subtract this one here, remember we have to, first step is always, we're going to rewrite the subtraction as an addition problem. first polynomial does not change. It's only the second one that changes. So right now, this is what we have. And basically, we're going to add the opposites. So this becomes addition. This becomes a negative. This becomes a positive. This becomes a positive. Once you change it to do addition problems, this is from where you can then now choose any method. Okay. Any of them work. For the algebra tiles, there's the first polynomial, and now I know the second one that I'm adding, it's negative 9g squared, so I need 9 of these here. It's easy to lose count too. One more. 2g's and 5 1's. So if you are using the algebra tiles, remember what you're trying to do once you get all of those tiles there is an assignment. It's going to be a time, so it's not math related. If you match up all your 0 pairs, and there's a lot of them here. It's just one way to do this. Try to cancel out as many 0 pairs as you can. Right, and so this is what I'm left with. I have negative x squared, negative x to the second power, but not x, right? It's g. Negative g to the second power. And it looks like I have 5 x's, or 5 g's, and 1 1. So, you know, if you're using x over here, this is always x on the algebra tiles, but this is whatever letter it is. Last step here is to evaluate it when e equals 5. Okay, you're going to replace negative the 5 there, and then you're squaring 5 plus 5 times 5 plus 1. Okay, so negative g, I think I have to have no, that's right. Okay, so this is negative 25 plus 25 plus 1, which is then equal to negative 25 plus 25 is 0. 0 plus 1 is just 1. Okay, so last part here, I know I'm a couple minutes over. At a rate of 5 gallons per minute, the change of the volume will be 1 gallon per minute. Right, and that is it. So I'm going to unlock your async time activity, which is an iTime activity. I'll get your